In discussing Boolean expressions that are expressed as sum of products, but you have not stated categorically that the form that we have been dealing with are sum of products. So we now deal with them as to make them quite clear. We say that a logic expression is said to be in the sum of products form if it gives an OR operation of logic functions that are in add form. That may appear a bit complex to fathom, but it is simply meaning that y is equals to ab plus bc plus ac. This is a and this is an and. So this is the add form, but then each of these are joined with an OR operation. So that is what it means, that whenever you find you have logic functions that are joined with, okay, in the add form, that are joined by the OR operation, then we say that that form of Boolean expression is in sum of products. For example, the logic expression below is in the SOP form. It consists of an OR operation from some three terms. So as you can see, we have an add, but then each of those add are combined with an OR operation. So the terms A, B, C, and B, all those are each expressed with an add operation, and again they are combined using the OR operation. So we'll consider an example of a logic expression with three variables A, B, C, and you notice that this doesn't have that prime. So in general, we say that an expression y with the variables a, b, c may be represented as shown in this equation here. If you are to give them in terms which you'll see how they come, this would be a 7, this would be a 6, a 5, a 4, a 3, a 2, a 1, and a 0. You'll see how we are getting those ones, but that is how you represent a y with three variables a, b, c. Now each of these terms is called a mean term. So these are mean terms, and we normally denote them as mean terms 0, 1, 2, 3. We have labeled them. Thus, A, B, C is the zeroth mean term. A, B, bar, C, bar is the zeroth mean term. That is why I graded with 0. Remember, when you're talking about kernel maps, you say a prime or a bar represents value 0 for the state of that variable, and therefore when we have a bar, that means a is 0, b bar is 0, and c bar is 0. Then we are saying 0, 0, 0. If you represent it using binary representation, then you would realize that this represents 0. That's why we are calling it zeroth mean term, and it is designated as m0, which is small m with a 0 as subscript. And just notice that when we say small m, which is not capital, it's very important to notice, because when we are talking about max terms, when we are dealing with the other product of sums, we'll be talking about capital M with 0. So notice that this is small m, and notice that very carefully. So we say that it can be noted that M0 corresponds to cell 0 in the K-map. Therefore, the way we had a K-map with, say, 16 variables, and we are giving them cells number 0, 1, 2, 3, you'd say cell number 0 is equivalent to mean term 0. All the mean terms in the Y are defined as follows. M0 is the one represented or represents variables a bar, b bar, c bar. Mean term 1, just like I mentioned, represents a bar, b bar, c. This is equivalent. Whenever you see that, it is like we are saying this is 0, 0, 1. Therefore, when you look at the binary representation, you can see that this can be used to represent 1. So we give it mean term. Similarly, the others are the same. This is 0, 1, 1, 0. Therefore, when this is represented in binary notation, this is equivalent to a 6. That's why we say that this is mean term 6. So the expression y can then be written in as a function of mean terms, and we normally say that y is equals to m0, m1 addition, or this is the OR operation, like we already noted. So OR is represented by a plus sign, and therefore, since we have saying that our y is an OR operation of these products, then we say that this is mean term 0, mean term 1, blah 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 blah, until we have mean term 7. And for that reason, we can then represent our y in this form. So this above expression is usually given in a better form, such that we say that sum, this is the symbol we use for sum, of mean terms 0, 1, 2, 7. So we are simply saying that you can express this y as sum of mean terms, the same thing we have said here, and the mean terms are symbolized with their digital equivalent of 0, 1, 2, 3, 4, 5, 6, 7. So for instance, we have an example given the following expression, express it as a function of mean terms and hence simplify it using K-map. Very simple equation which we can look at very briefly. And what we know is that whenever we observe such a logic expression, we want first and foremost to identify the number of variables that are used to represent this function. And whenever we see A, B, do not stop there. Look at all the other variables and identify all the variables that are represented. And here we can see we have A all the way from A to Z to D. That means there are four variables. So therefore, you're going to need a 4-variable K-map. Number two, if that be the case, you cannot say that A being bar represents 0 or 1, 0, and therefore you say this is mean term 2. What you need to do is to consider what could the other variables C and D be. And as we noted earlier, the CD can represent 4 other possible states like CD bar, C bar D, and C bar D bar. And therefore, those are the things we are going to look at, but we will see we don't need to develop these extra terms because we are not using the basic axioms or laws of Boolean algebra. We are using K-map, and K-map provides a visual representation of how to do that. So what we'll see is that we just need to fill in this K-map so that we can be able to see how we can best simplify it. And as we have identified, we have 4 variables A, B, C, D. We fill in our gray code representation. Once we have done that, we don't need to break this the way we have said before that we include the CD. All we need to do is to identify which column does A, B bar belong to, and we can see that A, B bar belongs to here because this is 1, 0. So this is A, B bar. Therefore, because we do not know what the other values of C and D are, all we need to do is to feed in here with this column with 1s. Again, we identify A bar and CD. CD is this one, and A bar can be here or here. So where the 2 columns and this one row intersect, you put a 1 there and there. So this one we say is represented A bar, B bar, this one, and C is here and here. We can see that this becomes a 1, and finally A, B bar, this one is already filled up. So this forms our K-map, and we can now express this as a function of mean terms by saying that our Z is equals to, we can remember how we name these cells 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we just need to identify where we have 1s, that becomes our mean terms. So we have sum of mean terms. We normally arrange them again from the smallest to the biggest. So we say 2, 1. So what we have here is that since we know the cell numbers, we pick the cell numbers that have values of 1. So, and we order them numerically. So we start with 2 as 2 there, 3, 7, and these other 4, 8, 9, 10, 11. Therefore, we say that we can express Z in terms of mean terms, which we have said the sum of mean terms M, small m, 2, 3, 7, 8, 9, 10, 11. And the next thing we want to do is identify how groups are formed. We can form a group of 4 1s, and these 4 1s, and these 2 1s. And we look for the variables that are not changing. And in this one, we can see this one remains at 1, 0. And for that reason, we can say that A is uncomplimented and B is complemented. Therefore, we have A, B bar. And in the group of 2, CD remains at 1, 1. Therefore, we have CD. But here we can see that A remains at bar, while B is changing. That's why we're having A bar C D. Finally, this group of 4, we can see that C is the one that is not changing. It remains at 1. And when you move from this column to this column, you see that the B is remaining at 0. So that is why we have B bar. And finally, we say that we can express Z as sum of these products. That's why we are calling it sum of products. So this is A, B bar, this one, and then B bar C, this one, and A bar C D, that one. So that becomes the simplified value of Z, which we have used K-map method to simplify.